Hi everyone, Kathy here with the Math Collective. Today I'm really excited to share with you one of my all-time favorite games. It's called Make 10, and it's a simple card game that can be adapted for implementation with students as young as TK Kinder all the way up to our middle school, high school students. So I hope that you enjoy. We're going to begin by taking a few minutes to talk about why I say let's play. Oftentimes I visit kindergarten, first grade classrooms, and you see students engaging in collaboration and play and playing games. And as you start to see students getting older, the opportunities for games and play greatly diminish. So today I want to consider how can we bring in games into our upper elementary and older classrooms so that students can really engage with math concepts and build those interpersonal skills and that collaboration in these upper grades. And here is a huge list of the reasons why it's really important for us to say it's okay for you to play in these grade levels. From the fact that games are student-centered and promote equitable access, to the idea that a game can be aligned to grade level concepts and have a low floor, high ceiling so that it invites the participation of all of our mathematicians. Games have the potential to spark curiosity and creativity and allow our students to make sense of complicated concepts on their own in a really authentic way. So whether you're working with younger students or older students, games really have a place in all of our classrooms. As you can see, I have set up my board game. I shuffled the cards and set up an array that's a 3x3. And it's a really simple game. In this version of the game, I've assigned values to our special cards, our ace, our jack, queen, and king. And you could see that the ace is equal to 1, the jack is equal to 11, our queen is 12, and the king is 13. And I like to have those values visible for our mathematicians somewhere in the classroom so that they can reference that. So when it's a player's turn, they can choose how to use addition and subtraction to make 10. So take a moment to look at our board and see if you come up with a move that can make 10 using addition or subtraction. If you need a little bit more time, feel free to pause and look at, there are a lot of combinations on this board, but we're going to keep going. So you might have a mathematician see that there is a 9 and a 1. And they might say, well, 9 plus 1 is 10. And that they want that to be their move. So they would take those two cards and then replenish those cards with new ones. You might see a mathematician just want to take this 10. And that's also a valid move. So they could just say, well, I know that 10 equals 10. And that they would take that one card and they would replenish the card, and then it would be the next player's turn. There are a few other combinations of 10 that are visible here. You could think about, how can I get to 10 from 11? Well, 11 minus 1 is 10. They might choose to use our queen and the 2 because 12 minus 2 equals 10. And then the game keeps going. So basically, each turn, a player tries to make a combination of 10 using addition and subtraction, or subtraction, either way. And sometimes they ask, can I take more than 2 cards? And the answer is absolutely. So you might have a mathematician who knows that 3 plus 2 equals 5, and that 5 plus 5 equals 10. And they would take those 3 cards in their move. And the way that you win the game is the player who has the most cards, either at the end of the card deck or at the end of the allotted amount of time, is the winner. So as they get more comfortable playing the game, they'll try to move beyond that, just taking the 10, and think about, how can I strategically have more moves or more cards in my move? But it's a really great example of how there's a low floor, high ceiling to this game. Someone might be comfortable sticking to 9 plus 1 or just the 10, and that's fine. Or you might have other students who now want to do several moves in order to make 10 because they're thinking, I'd like to collect the most number of cards. So that's just how some ideas about how to play one round. I'm going to go ahead and show you a video of a mathematician who's engaging in this game, and I hope that you really enjoy it.
And then, I don't remember how I grab them.
Try it. What would you do now?
And then I do -3 equals 10 plus 8 equals 18. -8 plus 4 equals 14.
Hold on. So if you did 18 minus 8, what is that?
10. And then if you add 4, it makes 14. If you minus 5.
So you had 10.
So I have 10 here. And then plus 5 equals 15. And then minus 5 again.
What is that now?
10.
Okay.
And then plus 10 equals 20. And then minus 10 again equals 10.
In the video that you just watched, you saw a first grader playing Make 10 for the first time. And the thing that's so extraordinary about that is that she was able to use flexible problem solving combinations to make 10, using 10 as that benchmark number to add up to the teens and add and subtract down in such a flexible way. And so the way that I use this video is that I share it with mathematicians once they've had a chance to play the game for about 15-20 minutes. And it really just lifts that level of thinking and the strategic moves that mathematicians make when they are given a little bit more time to play. I imagine that now that you've seen her navigating the different moves and thinking so strategically about how she can take all 9 cards, that if I presented that first game setup to you again, that you would be able to think about how could I try to take more cards or to think really flexibly about the numbers and the moves. So that's one of the reasons why I love sharing that video with a first grader, with students, and with adults that I'm teaching how to play this game, because I think it just lifts that level of thinking and it just sparks that curiosity. I think that it's really an exciting thing to consider, pushing your ideas about a game and challenging yourself. So one of the other things I want to point out about the video is that there was a point near the end where she had 4 cards left and she was trying to take all of the cards, and it became really apparent that she was trying to take all of the cards. And there was a moment where I saw how she could do it. And it was very, very important to point out that I did not help her. That wait time and that space for her to problem solve and puzzle and to productively struggle is so critical to our mathematicians. And even though the well-intentioned humans among us want to sweep in and say like, oh, this, you could just do this, she was able to figure it out. And I think that part of the discipline of being a math educator is taking that time and giving our mathematicians a chance to solve it for themselves. And it's okay to have silence and wait time. And look at how she was able to figure it out on her own and what that teaches her as a mathematician about herself, that she doesn't need an adult to help her out. And I was there prompting her, asking guiding questions when she felt stuck. But at no point did I say, did you consider taking these 2 cards, make a 10? Or, oh, it's really easy if you just make 5 this way. So just a little bit of food for thought. We're going to watch one more video. And in this video, we have a group of 4th graders who are playing this game. And same idea. I want you to just think about what was this experience like for them and what does it leave you thinking about as a math educator.
Okay.
So the queen is
12 minus 2.
okay. Very nice.
Okay, so I'll just plus this.
Can you walk us through what you're doing?
Okay, this plus this will be, I'll set it. This plus this will be 17. Oh yeah, 17. Then plus this will be 25. Then 25. So 25 minus this, so 10. 25 minus 10. Wait, I need to think
15.
a little bit. I think I can use this. So this minus this will equal 10.
That's 25?
Yeah.
And that's
Well, is this? I think it is. Yeah, it is 25. And this 15.
do you guys
25
agree? It's 25
minus
minus 15 10?
equals 10.
Yeah, it's 10.
Yeah, it's 10.
So here you had a chance to watch a couple of fourth graders engaging in this game. And I think that I love this video because it showcases that low floor, high ceiling nature of Make 10. You have one student who's comfortable pulling 2 cards and explaining to you that 12 take away 2 is going to get you 10. And that's where that mathematician is at the moment. And then the partner, the next person, is pushing their thinking even further. They want to see how they can take more cards, and they're thinking strategically about adding up and then taking away a bigger chunk to get to the 10 so that they can collect more cards. And as a teacher, just kind of trying to illuminate their thinking and their strategies among the group and getting them to explain their thinking to each other and to listen to the ideas of one another is something that's an ongoing goal and effort for us. It aligns really closely with our math practice standards of critiquing the reasoning of others and being able to articulate our ideas. But you could see the potential in this group of the students to learn from and to start to question one another about how they got what they did and why they made the decisions they made to get to 10. The next piece of this work is connecting the games that we play to our math instruction on other days. So one way that's really easy and quite seamless to do this is to integrate components of Make 10 into our warm-ups before a math lesson. So what that could look like is setting up an array of cards, taking a picture and presenting that picture as a math warm-up at the beginning of your next math lesson. Asking mathematicians, how many different ways can you make 10 given this picture of cards? And having mathematicians turn and talk to each other or list as many different options on their paper. So just bringing it back into their math routine and to their learning, and it doesn't have to just live as an isolated game. Another idea is ways to make, or how many ways can you make, and put the number 10. And they've had practice thinking about those 10s recently by playing the game. And even in a middle school level or at high school level, the way that they can make a really simple number like 10 could become really, really complicated. Think about integrating exponents or square roots or just the different ideas that can come up with 10 from TK, kindergarten, all the way to middle school and high school. There's a lot of potential there for this one. Another option is to have students write down one of their favorite number sentences or equations while they're playing. So what I like to do is to set up a fresh poster sheet or a whiteboard and to encourage our mathematicians to just record one of their favorite number sentences or equations that they're really proud of during the whole game. And then you end up with a series of equations that you can then draw from for other purposes. And one of those routines that you can integrate them into are true-false number sentences. Our mathematicians start to see equations and the idea of is this true or is this false on a lot of the assessments that they take. So by harnessing the work that they're doing while they're having fun and playing games into a routine or as a next step follow-up to the game really is a lot of potential to keep them hooked, keep that level of engagement really high, and then connect it to something that they're going to see in a more abstract form, like an equation or a number sentence, or are these the same? Something to note with true-false number sentences is it's important that they're not always true. So once you set up one that's false and you understand and the students talk to one another about why it's false, you can invite them to revise it. What changes would you make in order to make this number sentence true? It's really important to just take some time and reflect on the ways that Make 10 creates space for curiosity, exploration, and problem solving. I think it's also really important to note that as educators, we have to continue to create space for our students to collaborate and engage in problem solving and just to continue to hone those interpersonal skills that are going to set them up for success after school and in their careers. So, thinking about how it's so important to bring in our math games in order for them to practice these skills that will then set them up for success in their future lives. Thank you so much for being here today and listening to this session. I hope that you will leave comments if you try out the game. Please let me know how it goes. If you have any questions or if you would like some ideas for how to differentiate this game, let me know. And of course, please stay in touch. Thank you so much.